Live attenuated vaccines. These vaccines contain a weakened form of the living virus or bacteria that causes the disease. The microbe is altered so it can still replicate inside the body, but it cannot cause serious illness in healthy people. Because it closely mimics a natural infection, it triggers a very strong and long-lasting immune response. Common examples include the MMR vaccine for measles, mumps, and rubella, the oral polio vaccine, and the chickenpox vaccine. However, these are usually not recommended for people with weakened immune systems. Inactivated vaccines. In this version, the virus or bacteria is completely killed using heat, chemicals, or radiation. Even though the pathogen is dead, it still carries the antigens that teach your immune system to recognize the real threat. These vaccines often need multiple doses or booster shots to keep protection strong. You'll find this type in the injected polio vaccine, hepatitis A shots, and most seasonal flu vaccines. They are considered very safe for almost everyone. Subunit vaccines. Subunit vaccines only use specific pieces of the pathogen, usually proteins or sugars from its outer surface. They never contain the whole organism, so there's no risk of causing infection. These pieces are either extracted from the pathogen or made using genetic engineering. Popular examples include the hepatitis B vaccine and the whooping cough part of the DTaP vaccine. They generally cause fewer side effects than whole pathogen vaccines. Toxoid vaccines. Toxoid vaccines work by targeting the harmful toxins produced by bacteria, rather than the bacteria themselves. Scientists collect the toxin and chemically inactivate it so it can no longer cause damage, but it can still train the immune system. This method is used for tetanus and diphtheria. That's why your tetanus booster shot is a toxoid vaccine. Protection from these vaccines tends to fade over time, so regular boosters are important. Conjugate vaccines. Conjugate vaccines were developed specifically to help young children's immune systems respond better. They combine bacterial sugar molecules with a strong protein carrier. This combination makes the vaccine much more effective in babies and toddlers. These are used against serious diseases like Haemophilus influenzae type B, pneumococcal infections, and meningococcal disease. They have saved millions of children worldwide. mRNA vaccines. mRNA vaccines are a newer technology. They deliver instructions to your cells telling them to temporarily produce a harmless piece of the target virus, usually a spike protein. Your immune system then learns to recognize and fight it. The Pfizer and Moderna COVID-19 vaccines are the best known examples. These vaccines are fast to develop and very adaptable for new threats. Viral vector vaccines. These vaccines use a different, harmless virus as a delivery vehicle. This carrier virus is modified to transport instructions for making the target pathogen's protein into your cells. The Johnson & Johnson COVID-19 vaccine and some Ebola vaccines use this method. The vector cannot cause the original disease but trains your immune system effectively. Polysaccharide vaccines. Polysaccharide vaccines are made from the sugar coating on the surface of certain bacteria. They work well in older children and adults, but they don't produce strong immunity in infants and very young children. The original pneumococcal vaccine and some meningococcal vaccines belong to this group. Many have now been improved into conjugate versions. Recombinant vaccines. Recombinant vaccines are made by inserting a gene from the disease-causing organism into a harmless carrier like yeast or bacteria. The carrier then produces the vaccine protein in large amounts. The hepatitis B vaccine was one of the first successful recombinant vaccines. This method is very safe because it never uses the actual dangerous pathogen,